Good morning, sunshines. Yay. So today we're going to talk about what you use to build sets. Again, very esoteric, just no design part of it, just the things that are out there for you to use, for you to design from. First of all, I'm going to tell you 6 things about all these things that are materials and why they're used in city construction. First of all, these 6 things are all lightweight. They are all inexpensive, relatively. They're all durable. In other words, they don't just waste away or they get wet and that sort of stuff. They're reliable. You can count on them. They fit into the time frame for the most part. Most of these things are available at Lowe's, are available at local fabric stores, all that sort of stuff. But occasionally you may come across something that you have to order. But if it doesn't fit into the time frame, it's not usable in theater. And the last and probably the most important thing about these things is they're all safe. Yes, because if they're not safe, it's just theater, it's just play. So we don't need to be killing people around here. Let's talk about what they are. The first material we use a lot of is wood. Woods are trees. They're dead plants. They have, you mill the wood, you cut it down, you mill it. There are 2 basic types of trees. There's conifers, which they have cones, because of conifers. They typically are softwoods, is what they're called, evergreens. There tends to be more of those used because they grow year-round. The hardwoods are what are called deciduous trees. They have leaves that they lose during the course of the year, so there's a part of the year where they grow faster than the other part of the year. And even though this is not necessarily totally true, hardwoods, because they grow and then don't grow and then grow and then don't grow, tend to be more dense than softwoods, which grow continually year-round. Yes, that is not always the case, but in most cases, hardwoods like oak and that sort of stuff, cherry, are harder than the softwoods like spruce, pine, and fir. Cool. The first thing you're going to find out is that, let's do a little basics of wood here. There's a little introduction to what wood is. Enjoy.
In this video, you will learn the basics about wood. What is wood? Wood is obtained from trunks and branches of trees. It has been used for thousands of years for fuel, construction, and the making of tools and furniture. This lesson has been divided into 2 parts: the types of wood and the physical aspects. Types of wood. There are several different varieties of wood. Solid wood expands with moisture and contracts during dry months. This is an important factor to keep in mind while making doors and drawers, for example, which could expand considerably during the rainy season or winters. A rosewood mallet head, a piece of pine, a board of teak, and a board of red cedar, all placed on a table made of rubber wood. Woods can be classified in 2 broad categories: hardwood and softwood. Hardwood refers to timber harvested from broad-leaved, flowering trees like rosewood and teak. They are generally harder, as the term suggests, and are commonly used for cabinets, doors, and striking tools. This rosewood mallet head can deliver a powerful blow with minimal effort. Teak is renowned for its aesthetic value, workability, as well as its resistance to decay. Softwoods such as pine and red cedar are lighter and generally easier to work with. They grow much faster and are lower in cost, mostly being used for construction purposes. Pinewood is extremely easy to work with and exudes a sweet aroma. Apart from solid timber, you also have manufactured boards, such as plywood or MDF, which are more affordable but aesthetically less appealing. Plywood is made by gluing together thin layers of wood veneer. The grain in each layer of plywood runs perpendicular to the previous one, making it structurally strong. Rubber wood is extremely vulnerable to warp and rot, and needs to be treated with preservatives and laminated to improve its durability. Boards of rubber wood are made with edge-glued or finger-jointed pieces. Physical aspects. A solid wood workpiece generally has grain patterns resulting from the arrangement of wood fibers. The most basic pattern is the straight grain that runs parallel to the longitudinal axis of the workpiece. Generally, when you cut or plane a workpiece, make sure that you do it along the grain. When you cut a piece of wood across the grain, you have an end grain on the side. The patterns on wood also include knots. These indicate the starting point of a branch or a dormant bud. Knots are imperfections in wood and often weaken the workpiece. Nevertheless, they can be exploited to add aesthetic value to the workpiece. The choice of wood depends on the project. We have just scratched the surface of wood. Enjoy your work.
So, when you get the wood chopped down and taken to the mill, the first thing they're going to do is rough cut the lumber, and the nominal size is 2 by 4. In other words, when they cut that first board down using the saw, they're going to cut it down to 2 inches by 4 inches. Then they're going to come back and they're going to sand it at about 1/4 of an inch off of every side. And so the actual dimensions of a 2 by 4 are 3.5 inches by 1.5 inches. 1.5 being the 2 side, 3.5 being the 4 side, yes? So that's the first thing you need to know about it, just because if you're doing a drawing of a 2 by 4, it isn't 2 by 4 and no dimensions. It's just called 2 by 4 because that's what it's originally milled to. And that is true of most lumbers. There's the size that they're cut to beforehand and the size they're cut to afterwards. Now, plywoods are made from what are called veneers, where you take it, instead of cutting through this way, you put a blade up and spin the log and rip off a little veneer of usually a 1/4 inch to an 1/8 inch thick veneer. And then you take those veneers and you cross grain them. So you lay a piece of veneer this way, a piece of veneer this way, a piece of veneer this way, a piece of veneer this way. Obviously, in order to have the grain going the same way on the top and the bottom sheet, you have to have an odd number of veneers. So there are 7 veneers in a 3/4 inch piece of plywood that alternate from long grain to short to long to short to long to short to long. Yes, 1/2 inch only has 5 grains or 5 veneers. Those are the type most you're going to deal with, 1/2 inch and 3/4 inch. But there's some 1/8 inch out there and that sort of stuff. One of the more popular brands of board is called Luan. It is made from trees from South America. It is readily available. It is inexpensive, but it is a sheet stock. Yes, masonite is press board is another way to look at masonite. It is basically a bunch of sawdust that's combined with some glue and pressed into a board. Yes, the 3 types of pressure that we deal with most in theater are tension, compression, and shear. Tension is when you take 2 things and you pull them apart, that provides tension. Compression is when you take the thing and push it together, and shear is when you take it and you push against the middle of it, yes? Wood is exceptionally good at tension and compression. Not so good with shear. That way you have to support it a lot. But that's one of the reasons that we use wood. It's cheap, it's readily available. Again, it can, especially with tension and compression, solve those problems without much of difficulty. Cool. The next thing we're gonna talk about is plastics. Here's a little video about plastics.
Today, plastics are everywhere. All of this plastic originated from one small object that isn't even made of plastic. For centuries, billiard balls were made of ivory from elephant tusks. But when excessive hunting caused elephant populations to decline in the 19th century, billiard balls makers began to look for alternatives, offering huge rewards. So, in 1863, an American named John Wesley Hyatt took up the challenge. Over the next 5 years, he invented a new material called celluloid, made from cellulose, a compound found in wood and straw. Hyatt soon discovered celluloid couldn't solve the billiard ball problem. The material wasn't heavy enough and didn't bounce quite right, but it could be tinted and patterned to mimic more expensive materials like coral, tortoiseshell, amber, and mother of pearl. He had created what became known as the first plastic. The word plastic can describe any material made of polymers, which are just large molecules consisting of the same repeating subunit. This includes all human-made plastics, as well as many of the materials found in living things. But in general, when people refer to plastics, they're referring to synthetic materials. The unifying feature of these is that they start out soft and malleable and can be molded into a particular shape. Despite taking the prize as the first official plastic, celluloid was highly flammable, which made production risky. So inventors began to hunt for alternatives. In 1907, a chemist combined phenol, a waste product of coal tar, and formaldehyde, creating a hardy new polymer called Bakelite. Bakelite was much less flammable than celluloid, and the raw materials used to make it were more readily available. Bakelite was only the beginning. In the 1920s, researchers first commercially developed polystyrene, a spongy plastic used in insulation. Soon after came polyvinyl chloride, or vinyl, which was flexible yet hardy. Acrylics created transparent, shatterproof panels that mimicked glass. And in the 1930s, nylon took center stage, a polymer designed to mimic silk but with many times its strength. Starting in 1933, polyethylene became one of the most versatile plastics, still used today to make everything from grocery bags to shampoo bottles to bulletproof vests. New manufacturing technologies accompanied this explosion of materials. The invention of a technique called injection molding made it possible to insert melted plastics into molds of any shape, where they would rapidly harden. This created possibilities for products in new varieties and shapes, and a way to inexpensively and rapidly produce plastics at scale. Scientists hoped this economical new material would make items that once had been unaffordable accessible to more people. Instead, plastics were pushed into service in World War II. During the war, plastic production in the United States quadrupled. Soldiers wore new plastic helmet liners and water-resistant vinyl raincoats. Pilots sat in cockpits made of plexiglass, a shatterproof plastic, and relied on parachutes made of resilient nylon. Afterwards, plastic manufacturing companies that had sprung up during wartime turned their attention to consumer products. Plastics began to replace other materials like wood, glass, and fabric in furniture, clothing, shoes, televisions, and radios. Versatile plastics opened up possibilities for packaging, mainly designed to keep food and other products fresh for longer. Suddenly, there were plastic garbage bags, stretchy plastic wrap, squeezable plastic bottles, takeaway cartons, and plastic containers for fruit, vegetables, and meat. Within just a few decades, this multifaceted material ushered in what became known as the plastics century. While the plastics century brought convenience and cost-effectiveness, it also created staggering environmental problems. Many plastics are made of non-renewable resources, and plastic packaging was designed to be single-use, but some plastics take centuries to decompose, creating a huge buildup of waste. This century will have to concentrate our innovations on addressing those problems by reducing plastic use, developing biodegradable plastics, and finding new ways to recycle existing plastic.
Again, with plastics, you're talking about a wide variety of them. Acrylics tend to be clear. Nylon tends to be stretchy. These tend to be made into ropes and that sort of thing. PVC, polyvinyl chloride, tends to be very tough. I would say the majority of buckets, things you're going to find, like this thing right here, are made out of PVC. Yes, that's a nice white PVC. You can heat it and shape it to any kind of form. Bakelite was one of the first plastics. And if you think about an old telephone, if you've ever had an old like 1930s, 1940s telephone, it's incredibly hard and incredibly difficult to break. but it's incredibly heavy. So that first thing we said about these materials, Bakelite is very heavy. And nowadays, not so readily available, but when I first started, it was. Styrofoam is beaded foam. Again, very, very, very light. Polystyrene is blown foam, where you take it and just put you blow it and make it expand. But again, those are a variety of different ways of using plastics. And again, which plastic you use, a lot of times it depends upon what you're having the plastic do. If you're trying to shape something, the styrofoam often works because you can take a router or something and actually shape it and add dimension to it and that sort of thing. So acrylic, if you're going to have something that's see-through, obviously is a better choice. Yes. Now, the next thing we tend to use is a lot of fabric. Obviously, all of our drops, legs and borders are made out of fabrics. Drops are painted scenery. Legs and the border are the masking. You have the side masking that typically is black in most theaters. The borders hang above the top, the legs hang on the side of the stage. The first set of borders are what are called tormentors. The first set of legs, I may have said that wrong. The first set of legs are tormentors. I think I said that right. The first border is what's called a teaser. Yes, but that's just your 25% knowledge just because you're in this class. And a lot of times those are the same colors as grand drape. So if you have a red grand drape, you'll have red tormentors and teasers. But again, that's for the proscenium theaters that have some money. A lot of theaters don't really have grand drapes of color and have those tormentors and teasers. There's also a type of drop that you can see through. It's called a scrim. Here's a little information about scrims.
It was a cold and windy night, and the hero of our story was waiting for a friend on a dark and eerie street corner. Alone. Or was he? No. Behind our hero was a dangerous villain. Where had she come from?
Well, she'd been there the whole time. She was standing behind a scrim. A scrim is a special type of fabric that can be translucent, transparent, or opaque depending on how it's lit. In theater, lighting designers use a scrim to hide something or someone until the exact moment they want us to see it.
Scrims are used to create all kinds of moods and effects, from scary to dreamy to surprising. All you have to do to change that effect is use different lighting implements on that scrim. So, if our hero wants to escape the dangerous villainess, all he has to do is shed different light on the scrim to make her disappear.
Will she return? Who knows?
Yes. Now the nice thing about scrims is you can paint both sides. So if you were lighting from the front and making the drop opaque, you can have one thing painted. And then if you light from the rear, you can have something different painted. Yes. Now, oftentimes, let's say, we'll talk about Death of a Salesman, the way he did this. He had the spring painted on the front and the winter painted on the back. So when the light shifted, the house structure was still there, which made it easy because the problem with scrim, you can't fill the holes in the scrim with the paint. If you fill the holes with the paint, then it becomes opaque. But if you dye it, if you use dyes, then the dye will typically just dye the thread and not fill the holes with paint. And so you can dye the front with one drop and dye the back with another one. They don't have to have anything in common. It works, trust me, where you can light one side or light the other on scrims. They're fantastic little pieces. The last curtain in the theater is what's called a cyclorama. The cyclorama is usually used for projection. Usually it's white. And it's usually used for like our red, blue, and green projection colors, as well as gobos projected on it. I really would hesitate to paint a cyclorama. It's better to buy a drop and paint it. And a lot of times drops can be rented, yes? Flats are fake walls. You can have soft covered fake walls, or you can have hard covered using Luan. Either one, you can have fabric or wood on your flats, but the flat, you have door flats and window flats, but those are all the walls on your set. Metal is also an extremely useful material at times. It does tend to weigh more, and because you have to weld it together, it can be, you have to have more, just a different skill set, not necessarily more skills. You just have to have a different skill set than working with fabrics and or wood or plastic. What we work with is what's called mild steel. It's a particular type of steel. Again, all steels are different combinations of lead and iron. Other things like aluminum, like brass are available to you. They tend to be a little bit weak for our purposes, and they tend to be a little bit more expensive for our purposes. But steel is still, especially 1-inch stock square steel tube, tends to be something that we use quite a lot of when we're using metal. Galvanized metal is any kind of metal that has been galvanized on the surface so it doesn't corrode, just so you know. There are several typical forms of metal. You'll have angle bar, which again is a sort of an L shape. You'll have what's called bar and rebar, which again doesn't have a hole in it. Rebar is a ribbed bar, is what that stands for. A rod is any kind of long, again, no hole in it, piece. It's a lot like bar, only it doesn't bend as much, it's a little bit thicker. An I-beam has been designed specifically. It looks like an eye, which is why it's called I-beam, but they're usually large and are meant to support a great deal of weight. A channel iron is used a lot of times for paths for wheels. If you have, it's usually shaped like a U channel, that sort of thing, and a lot of times you put it on the floor for wheels for a certain wagon to roll in, that sort of stuff. Of course, the problem with that is that you then have this channel that people can trip over. But again, that's one of the uses of it. Pipe, any kind of pipe, it's got a hole through the middle of it. And again, it's bar with a hole in it. I mean, or a rod with a hole in it. The nice thing about pipe is that for the normal standard size, so for a 1-inch bar versus a 1-inch pipe, because you have, if this makes sense, in a bar you only have this surface and this surface, so you'll have two surfaces that are resisting bending. In a pipe you have this surface, but you also have that surface and that surface. So it's 2 times stronger than a bar as far as resistance to shear, which again is the one we have a lot of problems combating. Cold joints are using things like flanges, that sort of thing, but then the warm joint uses welding or brazing. Here's a little video talking about welding.
Hi, I'm Steve Christina from Arc Academy. Arc Academy is a small beginner and entry-level welding school here in Chicago, Illinois. And what we do is we teach beginners how to weld, but everybody that comes through our door usually doesn't have any idea what welding actually is, which is the liquefaction of a base metal with heat and then they fuse together. And there's 3 most common systems that do this: MIG, stick, and TIG. And what we're gonna do before we jump in is have a review of all 3 of these processes. Before we get started, let's talk about the common characteristics of each process, okay? So in welding, you have 3 basic elements. You have your heat source, your filler metal, and then your shielding gas or your flux. So let's talk about MIG welding. MIG welding, the filler metal is your electrode and it's on a spool of wire, and it is also a shielding gas process. So the advantages to this is it's going to be much easier to learn because you preset all of your parameters. It's going to be much cleaner because you don't have any kind of slag process, and you can hit a wide variety of metal thicknesses. So if you're in a garage, in your shop, that is a great process to use. Stick welding, because it is a flux-based process, works awesome outside. Wind doesn't affect it as much, and it can also work on thicker metals really well. Another advantage of it is if your metal is dirty, if you're working on farm equipment or on a gate or even in your driveway, rust and debris don't affect it as much as the other processes. A few of the disadvantages of stick welding is you're going to have a lot of spatter, a lot of vapor, off-gassing, and fumes, so it's not something you want to do indoors too much. Another thing is, if you're working on automotive frame mounts, it's not the prettiest or cleanest weld. Usually when you're working on some sort of frame, you're either going to pick MIG or TIG. So some of the advantages of TIG welding is you're going to get the highest quality weld. It's also going to be aesthetically more pleasing. It's a pretty bead. And it also works great on thinner metals. But the only problem is it's very difficult to control because you're controlling all 3 of your elements in process. Your leg is controlling your heat, your opposite hand is typically controlling your filler metal deposition rate, and then of course you have a non-consumable tungsten electrode that is creating your arc as you move through the bead. This is considerably slower process as well, so usually when you're working on TIG welding, you're going to be working on stuff like a frame for a motorcycle, automotive, sheet metal, something in that regard. We've highlighted the advantages of each welding process. Now we got to talk about what you're going to do. All of my students that come up to me that are about to buy a welder, they ask me, which one should I get? Well, it really depends on what you're going to be doing most. If you are outdoors working on farm equipment, you're typically going to go with a stick welder, thick metal welding, dirtier material. If you're working on thin metals, HVAC, if you're doing frame outs, go with a TIG welding process. If you want a wider range and you're going to be working indoors, MIG welding is probably what you're going to want. Now let's get a little bit more specific about what metals you can use for each process. MIG will typically have the ability to weld steel, stainless steel, and aluminum alloys. Stick has the ability to weld on steel, stainless steel, and cast iron. Whereas TIG pretty much runs the gamut. You can weld on any metals that conduct electricity: steel, stainless steel, aluminum, copper, brass, chromoly, and exotic metals such as magnesium and titanium. We hope you enjoyed this video and you got a lot out of it. We highly encourage you to move on and watch the rest of the videos in this series. We break down purchasing a welder based on your needs. If you're looking for more educational videos, go to arcacademy.com. We have an entire library of learning tutorial videos where you can grow your knowledge of welding.
Again, I'm not making you a welder by any means, but again, the oxyacetylene welding is also the one you can use to cut through if you need to destroy some metal pieces. You can use the oxyacetylene to cut through the metal as well. The other MIG and TIG and arc welding only are there for joinery. Yes. All right, so that's a quick version of the types of materials we use. Next class period, your first paper is due, so please bring that with you next week. All right, we'll see you then.